Statistics using NumPy. Just like the built-in statistics module, performing various complex statistical operations in Python can be easily reduced to single-line commands using NumPy. NumPy stands for Numerical Python. It's a library that consists of multi-dimensional array objects and a collection of routines for processing arrays. If you're working with a really large dataset, like multi-dimensional array objects, NumPy is your better option. It's faster and occupies less memory in your computer. How is NumPy different from Python's statistics library? Let's find out by writing some code. Let's head back to your statistical functions tutorial notebook. Before we start coding, place a heading, NumPy Statistics. Now, you can start by importing the NumPy module and reference it as NP. By using the alias NP for NumPy, you can just type NP every time you call the NumPy methods. To easily pinpoint any differences from the Python statistics module, let's use the same dataset we used in the previous video. This time, let's name it f_usage. Now, instead of placing all the print functions at the end, let's create a function that displays all the results of our statistical operations. Take note of the variables. You need to make sure that these match the variables that we'll be declaring later. Now it's time to compute. The syntax for getting the mean, median, variance, and standard deviation in NumPy is the same as using the built-in Python statistics. We start with the module name, followed by a dot, then the method name. Since NumPy is designed for numerical computing, not specifically for statistical operations, it's more likely that we'll encounter some differences if compared with the built-in Python statistics library. First is the range. In NumPy, you simply call the PTP method. You don't need to get the maximum and minimum values. Next is getting the variance and standard deviation of a sample data. Here's our code in getting the sample data from our dataset. To compute the variance and standard deviation, an additional parameter, DDOF, with a value set at 1, is added to the variance and standard deviation methods. Last is about the mode. NumPy doesn't have a built-in method for mode. To get it, you need to import stats from the SciPy module. SciPy is another Python library for scientific numerical computing. Now, let's call the mode method from SciPy's statistics module. Don't forget to call the display_stat function to print the results. Let's run the code. Uh-oh, it looks like you don't have the SciPy module yet. To install the SciPy package, you have to stop the server running in your terminal first. Go to your command prompt and press Ctrl+C. Once you're in the myenv environment command line, type conda install SciPy. Once the installation is done, relaunch your Jupyter Notebook and restart your statistical functions tutorial notebook. Run your code again and check your output. They're all the same as the Python statistics module, except for the mode. You can see that the mode result is displayed in an array named modeResult with 2 attributes. The first mode is the mode of the dataset. The second, count, is the number of times the mode appears in the dataset. That's about it for now. In this video, we use NumPy in computing the common statistical operations in descriptive statistics. We also compare it with the built-in Python statistics module. In the next video, we'll work with another third-party Python library, Pandas.